Which car experiences a resultant force that is not zero? Okay, from all of these given options, all of these scenarios, we have to figure out which car is actually having resultant force that is not zero. So for option A, which is a car moving along a straight horizontal road at constant speed. Okay, if we have a straight horizontal road on which the car is moving with the constant velocity v, so the constant velocity means the acceleration is zero. Okay, constant velocity means the acceleration is equals to zero, and hence when the acceleration is zero, from the Newton's second law we know that acceleration is zero as a result of when the resultant force is zero. Okay, sum of all forces is zero, resulting in acceleration equals to zero. So this could not be the case because here force is zero. Now, a car moving around a bend at constant speed. Okay, let's analyze this case. We have this bend, okay, and the car is moving along this bend at constant speed. Okay, if this is having a constant speed v, now look, the velocity, the magnitude is constant. Okay, velocity is a vector quantity, right? Velocity is a vector quantity, which means it has a magnitude and direction. So velocity is constant, which means the speed is constant. Okay, speed is constant, which means the magnitude of the velocity will remain constant. But do we have the direction? Does direction changes or not? So see, when the car is moving around the bend, the direction of the velocities keep on changing, for this way and then this way and then this way, and it keeps on changing around the bend. So however, the magnitude is not changing, but the direction is. This means the overall velocity is changing, and changing velocity means there is an acceleration and there is a force. Okay, so this could be the case where the force is not actually zero. Why not zero? Because the direction is changing around the bend. Okay, when the direction is changing, this means the velocity is changing. Okay, next case is a car moving up a hill at constant velocity. Okay, so we have a hill and we have a car moving with a constant velocity v. Again, the velocity is constant, which means there is no acceleration, and the car is moving in a straight line, which means there is no change in direction as well. So acceleration is zero, hence the resultant force is zero. So this could not be an option for us. Now the next case is a car that is at rest. So a car simply at rest, v equals to zero, hence acceleration equals zero, and ultimately this resultant force is zero. So this could not also be the case too, and we can now go with option B.